So we're on, I think, almost the last segment of the vodcast for the mole. And today what we're going to do is pick up on a review of empirical formula and show how with one easy little multiplying step you can determine a molecular formula. So let's go back and review a little bit again. Remember, the empirical formula is not the true formula of a compound. Typically, a lot of compounds they are, like water, for example, H2O is both its molecular and its empirical formula because you can't reduce a 2-to-1 ratio down to another small whole number ratio. But for example, we learned that benzene, C6H6, that is its molecular formula, but its empirical formula is simply CH because a 6-to-6 ratio is the same as a 1-to-1. Well, now what we want to do is we want to see if we can go backwards. If calculating the empirical formula, you can get to the molecular formula. And the one thing that you would need to be able to do that is the same kind of information that you've had before, but with one last touch. So let's go with that. So for example, here's the formula for acetic acid. It's the molecular formula of acetic acid, but you can quickly see that that could be reduced down to a 1-to-2-to-1 ratio, CH2O. But a molecular formula tells you the exact number of each element and their atoms in the formula of a compound. And we just said this. So the thing that hopefully you can notice in that top box is that when you look at the formula for the molecular acetic acid, see how each of the numbers here are some multiple of each of the subscripts in the empirical formula. 2 times 1 is 2. 2 times 2 is 4, and so on. So what we'll be looking for is what is that little multiplier number so we can go backwards from an empirical into a molecular formula. Now to be able to do that, you'll be given the molar mass of the compound in real life. You will find the empirical formula according to the methods that we've learned and simply do a dividing process. Bigger number divided by smaller number. Molecular molar mass divided by empirical molar mass. And that will be our multiplier number. Now that's probably just gibberish. If you look at this flow chart, you can see that we're going to go from empirical formula to finding the multiplier number. We're going to do a multiplying step and we'll get to the molecular formula. For me personally, this graphic and that explanation don't help that much. I need to do a specific example. But very important, when you start a molecular formula problem, you'll know it and you'll search for the given information of the molecular molar mass. Without that, you can't do the problem. So let's do a sample problem. Maleic acid is a compound that's used in plastics and textiles industries, and now they've given us its percent composition. Hopefully by now it's become an automatic response that you find those little percents of carbon, hydrogen, and oxygen, enter your fantasy world, pretend you have 100 grams of the stuff, and change every single percent symbol that you see into grams. Once you've done that, oh, and notice, by the way, that they give you the molar mass of the true molecular formula. Just hold on to that number. We'll be using that later on. So once you've taken that percent composition, to find that empirical formula first, we're doing that step where we change percents into grams. Then by now, and hopefully this is a compulsive reaction that happens to you all year long in chemistry, you want to change grams into moles. So each of these 3 boxes here is showing how we're taking the grams of the given carbon, hydrogen, and oxygen and turning them into moles by dividing by each one's correct molar mass. And notice I was very careful to include all of the digits in the molar mass. And most importantly, when you do an empirical formula and therefore a molecular formula, always carry out those digits off to the right at least 3 places. If you try to abbreviate or round those off, you won't find the mathematical relationship as perfectly. Now, people good at math can look at these numbers and go, those kind of all look like the same number to me. But the rule was find whichever one of the 3 numbers is the smallest and divide all of them by that smallest number. So technically, the hydrogen is the smallest number of moles. But if you had done that, even though it says it's not necessary to divide by the smallest value, if you had done that, you would have found a 1 to 1 to 1 ratio. So the formula for the empirical formula for maleic acid would have simply been C, H, and O. More typically, you would have gotten one of those 2 to 1 to 2 or something, a small whole number ratio, or possibly you could have gotten the fractions of 1/2 or 1/3. And as we learned in the previous vodcast, multiply halves by 2 and multiply thirds by 3, and you'll get the smallest whole number ratio for the empirical formula. Now so far nothing is new. Nothing we've done so far for molecular formulas is new. Here's the new stuff. Now that you have the empirical formula, simply find its molar mass. So you're going to sum the mass of a carbon plus the mass of a hydrogen plus the mass of an oxygen. You get the molar mass of the empirical formula, and it's 29.018 grams per mole. We have one additional step then. We're going to take that given molecular formula molar mass, given to us earlier on in the problem, and divide it by this, the empirical molar mass. So this is going to be our multiplier number that we were talking about earlier. We'll take 116.1 divided by 29.018. That's the molecular molar mass up on top. Given in the problem always has to be given. Not given, can't do the problem. And here is the empirical molar mass that you found by finding the empirical formula first. Now we have a lovely number 4. This is our multiplier number. And it means that the empirical formula must have 4 times each of the subscripts in the empirical. Let me repeat that. The molecular formula must have 4 times the number of atoms that you see in the empirical formula. So simply multiply by each of the subscripts. In C, H, and O, we don't write 1s in chemistry, but now I have C4, H4, O4 is going to be the correct molecular formula for this maleic acid. Now we've given you one worksheet that has 4 problems on it, asking you to calculate first the empirical formula and then the molecular formula, and it's done in exactly the same process that we've done here. We'll be practicing on that in class as well. So I think you're at a good spot to be able to do some of these review problems. Please complete those in your PowerPoint notes showing the work, the complete work for how to find the percent composition of aluminum oxide. Here's the answer. Please also show the work for doing the percent composition of magnesium nitrate. Question number 3 gives you a percent composition and asks you to calculate an empirical formula, and you can test yourself to see if you know how to do these problems. And question number 4, same thing. We're giving you the percent composition to find an empirical formula, but then when they give you the molar mass of the molecular true formula, you know that they're going to be asking you to find the little multiplier number that gives you the molecular formula. That's silver oxalate. This section on hydrates is where we will stop. We will not cover hydrates before the exam on Tuesday, so you can stop here. We'll be doing a lab, a simple worksheet, and this will be the end of the mole unit. Take care.